Okay, this is homework 10 on solving differential equations. So let's go through the 6 problems. Problem 1, we have the differential equation y prime equals 6xy. So the way it's written on the paper is y prime equals 6xy, but this is not how you write it in Maple. So the differential equation, I'll call it ODE for ordinary differential equation. So how do you write y prime? It's diff for differentiate, or derivative of y of x with respect to x. This is the first derivative. Equals 6 times x times this unknown function y of x. That's the differential equation we're being asked to solve. And the command is dsolve. D stands for differential equation. And just write dsolve is ordinary differential equation. And that's the solution. C1 is just a constant. Right? So the general solution is a constant times e to the 3x squared. And you can check by differentiating that the derivative of y is 6xy. That's all there is to it. In problem 2, the differential equation is y prime equals x squared y cubed. So ODE is equal to derivative of y of x with respect to x equals x squared y cubed. X squared and y means the function y of x, and that's how we have to write it. Oops. Y of x cubed. But we don't want the general solution. If we wanted the general solution, we would just say dsolve the ODE. This is the general solution, which involves an unknown constant. But in this case, we have an initial condition, which I'll abbreviate as ICS. And the initial condition is that the function y at x equal 1 has the value 2. And now what I want to solve is the differential equation with the initial condition. So I put those in curly brackets. And once you fix the initial condition, this gives us the constants. Oops, this is not right. Y of y equals 2. Yep. So I notice when x is 1, 33 minus 24 is 9. Square root of 9 is 3, and 6 over 3 is 2. So that's it. That's the particular solution to this differential equation, satisfying this initial condition. Problem 3, we have the differential equation y prime equals y times 1 minus y. So this ordinary differential equation is derivative of y of x with respect to x equals y of x times 1 minus y of x. Oops, we got a bracket. There we are. So y prime equals y times 1 minus y. And the initial condition is that y of 0 is equal to 0.2. So if we solve this differential equation satisfying the initial condition, this is what we get. Now you should recognize that this is what's called the logistic equation. Which should be in your Math 176 syllabus. And if you plot this, this is the function we're plotting. The x goes from 0 to 10. That's what it looks like. When x is 0, it has the value 0.2. It looks like it's growing exponentially, and then it tails off and approaches 1 asymptotically. That's what it looks like. Okay. Problem 4, we have the differential equation y prime plus y equals sine squared x. So ODE is equal to dy dx diff y of x with respect to x plus y of x equals sine of x squared. And we have the initial condition that y of 0 equals 4. So let's desolve with the initial condition and the ordinary differential equation. That's what it looks like. Might be a little bit hard to do this by hand, but that's what it looks like. In problem 5, we have a second order differential equation. That means it's a differential equation that involves a second derivative. So this ODE, now how do we write a second derivative? It's DIFF y of x, comma x, comma x. This means differentiate with respect to x and then again with respect to x. So that's the second derivative. Plus 7 times the first derivative plus 10 times y, 10 times y of x equals 0. That's my differential equation. There's no initial condition, so we just want the general solution. Desolve the ODE. That's what it is. It's a linear combination of e to the minus 5x and e to the minus 2x. This is a constant, C1. This is a constant, C2. Problem 6 is another second order differential equation. In this case, it's y double prime plus 6y prime plus 9 equals 0. And we have an initial condition. There are 2 of them. So ICS, y at 0 is equal to 1. And the derivative of y at 0 is equal to 2. So again, it's very important to learn the syntax for this. This is a first derivative, diff y of x comma x, second derivative, diff y of x, and then two x's. And this is y of 0 is 1 and the derivative is 2 at x equals 0. So now when we solve this differential equation with the initial conditions, that's what it looks like. Notice that when x is 0, you get 1 plus 0. And when you differentiate, you'll see that you actually get 2. So that's how you do it. That's the whole story.